Have you ever wondered how data in databases maintain their accuracy and consistency? It's all thanks to a concept called relational integrity, sometimes known as referential integrity. This concept is the bedrock of relational database systems, ensuring that the relationships between different tables of data are accurate, consistent, and most importantly, reliable. How does it achieve this? Through the application of constraints and rules defined within the database schema itself. These rules make sure that the data stays faithful to the relationships they're supposed to represent. There are two main aspects of relational integrity: entity integrity and referential integrity. Entity integrity makes sure that each row within a table is unique, while referential integrity ensures that relationships between tables are consistent. These two work hand in hand to maintain the integrity of data stored in databases, keeping it accurate and trustworthy. Relational integrity is a fundamental aspect of data management that ensures the quality and reliability of data stored in a database. The first aspect of relational integrity we'll delve into is entity integrity. Simply put, entity integrity is a fundamental principle in database design that guarantees uniqueness and singularity of records within a table. Just imagine a library catalog where every single book is distinct and identifiable, regardless of how many copies exist. That's the essence of entity integrity in a database, ensuring every row, like every book in our library example, is unique and identifiable. Now, how do we achieve this uniqueness? The answer lies in the use of primary keys. A primary key is a special type of database column designed to uniquely identify every record in a table. It's like the ISBN number for a book, or the social security number for an individual. When we define a primary key for a table, we are setting up a rule that says, hey, no two rows in this table can have the same value in this primary key column. This rule is known as a primary key constraint, and it's a powerful tool for enforcing entity integrity. Let's delve a bit deeper into this. A primary key constraint has two important conditions. First, it does not allow duplicate values. This means that no two rows can have the same value in the primary key column. It's like having two people with the same social security number. It just can't happen. If you try to enter a duplicate value, the database system will say, sorry, no can do. The second condition is that a primary key cannot contain null values. In database lingo, null is a special marker used to indicate that a data value does not exist in the database. However, a primary key needs to be a reliable, always there kind of identifier. So having a does not exist value for an identifier, that's a big no-no. Enforcing these two conditions, no duplicates and no nulls, is how a primary key constraint upholds entity integrity. It's like a dutiful librarian ensuring that every book has a unique catalog number and that no book is ever without one. So why is entity integrity so important? Well, without it, we could end up with duplicate records, which can lead to confusion and data inconsistencies. Imagine trying to update a record but not knowing which of the duplicates to update. Or consider the inefficiencies of having the same data stored multiple times. In a nutshell, entity integrity is about ensuring the one and only status of each record in a table, making it uniquely identifiable. It's the gatekeeper, ensuring that every row in a table is as distinct as a thumbprint, as unique as a snowflake. By enforcing entity integrity, we can prevent the existence of duplicate or null values in primary key columns, ensuring each entity instance is uniquely identifiable. This way, our database remains reliable, efficient, and user-friendly, just like a well-organized library. The second aspect of relational integrity that we will explore is referential integrity. Referential integrity is like the glue that holds tables together in a relational database. It's all about maintaining the consistency of relationships between the tables. Imagine you're hosting a dinner party. You wouldn't want to set a place for a guest who's not coming, right? That's what referential integrity prevents in the world of databases. This kind of integrity is enforced through foreign key constraints. A foreign key is a column or a set of columns in one table that is used to reference the primary key columns in another table. The foreign key and primary key act like a pair of old friends. They always know how to find each other. This relationship between the two keys is the cornerstone of referential integrity. But why is this so important? Well, it's because referential integrity ensures that you can't have a foreign key value in one table that doesn't match a primary key value in the related table. This is crucial because it prevents the creation of orphaned records. Now you might be asking, What exactly is an orphaned record? An orphaned record is a row in a table that references another row that does not exist. Going back to our dinner party analogy, an orphaned record is like having a place setting for a guest who never shows up. It's a mismatch, a discrepancy, a violation of referential integrity. And trust me, in the world of databases, this is a big no-no. Common actions that can violate referential integrity include trying to insert, update, or delete rows in a way that would create these orphaned records. For example, if you try to insert a row with a foreign key value that doesn't match any primary key values in the related table, you're trying to invite a guest who's not on the list. That's a violation of referential integrity, and the database system won't allow it. Similarly, if you try to delete a row that's referenced by a foreign key in another table, you're trying to remove a guest from the party while their place setting is still on the table. Again, that's a violation of referential integrity, and the database system won't allow it. So you see, referential integrity is a crucial aspect of relational integrity. It keeps our tables in sync, it prevents orphaned records, and it ensures the overall consistency of our data. It's like a strict but fair party host, making sure that every place setting matches a guest, and every guest has a place setting. Enforcing referential integrity ensures that all references to data in one table are valid and consistent with the data stored in related tables. Now that we understand what relational integrity is and how it works, let's talk about why it is so important. Relational integrity is the guardian of accuracy and consistency in a database. Think of it as the database's immune system, protecting it from data anomalies that can cause corruption and errors. It's like having a meticulous librarian who ensures that every book is in its rightful place, and that there are no missing or duplicate volumes. Enforcing entity integrity is like assigning unique barcodes to each book. This allows us to confidently retrieve, update, or delete any particular book because we know it's the only one with that specific barcode. Without this, we run the risk of having duplicate books, or worse, not being able to find a book at all because it doesn't have a unique identifier. On the other hand, referential integrity is like the system that ensures books referenced in a bibliography actually exist in the library. It's ensuring that if a book points to another as a reference, that referenced book is indeed there. If not, we'd have a broken link, leading to confusion and mistrust in the data. Common actions that can violate referential integrity, such as inserting, updating, or deleting rows in a way that would create orphaned records, are like citing a book in your bibliography that's been removed from the library. It's a dead end, a frustrating experience, and a blow to the credibility of your work. So by meticulously enforcing these integrity constraints, we maintain the accuracy and consistency of data in our database. We avoid the chaos of duplicate records, the confusion of inconsistent relationships, and the frustration of data inconsistencies. In essence, relational integrity is not just a nice-to-have, it's a must-have. It's fundamental to the reliability and quality of the data stored in your database. It's what keeps your database healthy, trustworthy, and effective. By enforcing entity integrity and referential integrity, relational database management systems ensure the reliability and quality of the data stored in the database. So, what have we learned today? We've dived deep into the concept of relational integrity, understanding its two main aspects: entity integrity and referential integrity. Entity integrity, with its unique primary keys, ensures each row within a table is uniquely identifiable, eliminating the risk of duplicate or null values. On the other hand, referential integrity maintains the consistency of relationships between tables. It guarantees that foreign key values correspond to primary key values in the related table, ensuring all references are valid and consistent. Together, these aspects prevent data anomalies and maintain the accuracy and consistency of data within a relational database. They safeguard against data corruption and errors in database operations, ensuring the reliability and quality of the data stored. Remember, enforcing relational integrity is a crucial aspect of managing a reliable and effective database system. Thanks for watching, and be sure to subscribe for more insights into database management.